Hello students, welcome to the lecture on automation in design and manufacturing, and after this lecture we will be able to learn the following objectives. Explain the role of IT in world-class manufacturing, discuss the concept of flexible manufacturing system, describe the group technology, explain the cellular manufacturing systems. Let's start with the introduction. Manufacturing systems consist of human workers, automation, and various material handling technologies configured in ways that create specific manufacturing system typologies. More specifically, a manufacturing system is a collection of integrated equipment and human resources whose function is to perform one or more processing and/or assembly operations on a starting raw material, part or set of parts. Manufacturing systems that are said to be automated, and so concentration will be put upon the types of integrated equipment that is used and arranged in a manufacturing cell. This can range from production machines and tools, material handling, and work positioning devices to the use of various computer systems that facilitate automation in the production environment. Yet, manufacturing will still need people, if not so many in the factory itself. All these automated machines require someone to service them and tell them what to do. Some machine operators will become machine minders, which often calls for a broader range of skills, and certain tasks such as assembling components remain too fiddly for robots to do well, which is why assembly is often subcontracted to low-wage countries. Various efforts are underway to produce such robots, especially for smaller companies. Germany's Fraunhofer's Institute, for instance, is involved in a European initiative to develop robots that are safe enough to operate alongside workers. At present, most industrial robots still have to be caged in case they accidentally hit someone, and capable of understanding simple instructions including voice commands.
It's probably safe to say that most people love to buy things. They love to buy clothes, cars, cell phones, and even nice meals. Many people would probably also say companies in those industries would be exciting to work for. But would you feel confident running the manufacturing facilities? Yeah, manufacturing is perhaps the most ominous and mysterious portion of the supply chain. Because items today are rather complex, and because the distance between manufacturers and retailers is often so great, most people know very little about the manufacturing process. At best, they might guess some of the materials used to make it, or maybe where the item was made. But ask them how the item was actually created. Yeah, that's what I thought. Look, rather than try and figure out how each product or service is produced, let's figure out which issues a supply chain manager needs to consider in manufacturing a product. And to make it even easier, we'll consider manufacturing facilities near your home. Yeah, believe it or not, most of you live near modern manufacturing facilities. In fact, many of us visit these manufacturing facilities and assembly plants many times each week. Do you know what I'm talking about? Think about it. Yep, you got it, restaurants. Restaurants take raw materials and transform them into complex end items, just like manufacturing plants do. Before the first burger is ever served up to a customer, someone was responsible for designing the burger. Believe it or not, companies like McDonald's and Red Robin have research and development teams just like Ford and Sony. So, we need R&D to design an excellent burger. We need procurement to purchase the right ingredients, and we need to think about how to manufacture a burger that will still be delicious after the drive home. In running these manufacturing facilities, executives must consider trade-offs related to cost, quality, speed, and flexibility. Higher quality burgers take more time to manufacture and ingredients are more expensive. Offering the customer more options could be more costly and time-consuming to produce. But high-quality burgers made slowly with lots of customer options are more likely to be desired by hamburger lovers. So in order to make your dining experience perfect in a way that provides the restaurant a profit, an executive must understand what the customer is willing to accept as standard on a burger and what can be customized for each burger. And this will dictate decisions related to labor, machinery, inventory, capacity, and perhaps the restaurant's design and location. So, now you better understand that even manufacturing hamburgers is about more than material and labor cost. And it's only after considering design, manufacturing, and resources that companies can properly explore outsourcing, offshoring, and in the case of hamburger restaurants, franchising. So, next time someone says outsourcing decisions are only about low cost, you'll know better, right? Good. So, you ready to manage a Boeing facility? Look, manufacturing an airplane will always be intimidating, but hopefully now you have a better feeling about the important issues and considerations product designers and supply chain managers must confront in delivering millions of high-quality products and services to customers all over the world.
Let us now discuss the role of IT in world-class manufacturing. Information technology includes all the software, hardware, and resources that collect, process, observe, and execute information required for different activities of the business. The greater use of IT has been made possible with the advent of latest technologies and tools which are developed to facilitate all business processes. The significant role of IT in manufacturing sector cannot be denied. Mostly in manufacturing, use of IT refers to the multitude of business applications and computer technologies. Large wholesale quantities are now scheduled and managed properly with the use of different computer tools. MRP and ERP are important software for manufacturing businesses that are the outcomes of information technology. These software help US wholesale manufacturers to know what quantities are in hand, how much is needed further, and when. Thus, the use of them eliminates the need of storing extra inventories. In this way, cost of inventory storage is minimized, which helps in overall reduction of operational costs. The role of IT in drop shipping seems to be more significant. Use of order tracking software and delivery tracking software are an essential part of this business model. Without the use of IT, the model of drop shipping may not work just as efficiently. You manage customers' accounts on your PC, which is the outcome of information technology. Many such softwares are now available that keep the record of our customer in the form of last date of purchase, starting date, and the balance. The main goal of this IT infrastructure is to enable zero latency within and between business processes that have stakeholders that are distributed across the organization. The role of computer and information technology runs service operations. Service, by its definition, does not have a physical dimension. However, many organizations classified as a service provider actually produce both goods and services. These hybrid operations include restaurants which both sell food, a good, and prepare it, a service, department store which sells products as well as the retailing service, and shops that sell parts and offer repair services. Now, moving on to the next topic, we will study the concept of flexible manufacturing system. Flexible manufacturing systems, FMSs, are the most automated and technologically sophisticated of the machine cell types used to implement cellular manufacturing. An FMS usually has multiple automated stations and is capable of variable routings among stations, while its flexibility allows it to operate as a mixed model system. A flexible manufacturing system, FMS, is a highly automated group technology machine cell consisting of a group of processing workstations that are interconnected by an automated material handling and storage system and controlled by a distributed computer system. Flexibility is an important part of this definition. Where we discuss it in more detail, flexibility can have different interpretations, but it generally refers to the system's responsiveness to changing demand patterns so that the mix of part styles in the system and the production volumes that can be met can be adjusted rapidly to meet changing requirements.
The Flexible Manufacturing System is a versatile mechatronics training platform which integrates modular production, handling and processing, robotics, logistics, and material flow concepts. The FMS is comprised of 10 individual stations which can be used together or separately depending on the training and education needs. Workpieces are introduced as incoming goods via the distributing and testing stations. The pallet transport system delivers each workpiece to the handling and processing stations. There, the workpiece is drilled and tested in the processing cell. Next, the workpiece is transferred to the Vision System Station for quality inspection. The Vision System utilizes a combination of hardware and professional image processing software to control its functions. The workpiece is transferred to the robot and assembly stations for final component assembly. There, the robot uses its own control hardware to perform assembly functions and communicate with the transport system. The pallet transport system transfers the component assembly for warehousing by the automatic storage and retrieval station or for delivery as outgoing goods via the handling and sorting stations. The MPS stations and the pallet transport system are equipped with their own PLC control.
One of the most important aspects of manufacturing is having a sound, flexible manufacturing system. The ability to adjust to meet the customer needs without compromising the capabilities of the company is flexible manufacturing. It is crucial in today's world to avoid buying or using equipment monuments. These include anything that cannot be moved without extreme amounts of time, support, and expense. Monuments oppose manufacturing flexibility. They typically have one purpose in mind and do not adjust well to design changes as easily as multifunctional systems.
A flexible manufacturing system is a method for producing goods that is readily adaptable to changes in the product being manufactured, in which machines are able to manufacture parts and in the ability to handle varying levels of production. A flexible manufacturing system gives manufacturing firms an advantage in a quickly changing manufacturing environment. While an inflexible manufacturing system has many advantages, it may not always be the most cost-effective method of manufacturing due to the high cost of developing the system and obtaining sophisticated machinery. An flexible manufacturing system may be able to make up for this high cost with greater efficiency and less downtime. For example, a traditional manufacturing system may need to halt if a key machine breaks down. However, an flexible manufacturing system may be able to adapt and keep production going during repairs.
Today, companies such as SetPoint are leading the way into the coming future. Some important goals to achieve are quick changeovers, simple setups, adjustable equipment, smart robots, reduced inventory, producing to demand, satisfied employees, balance between automated versus manual systems, lean achievements through constant learning. There is a general consensus about the core elements. There are 3 levels of manufacturing flexibility: basic flexibilities, machine flexibility, the ease with which a machine can process various operations, material handling flexibility, a measure of the ease with which different part types can be transported and properly positioned at the various machine tools in a system, operation flexibility, a measure of the ease with which alternative operation sequences can be used for processing a part type. System flexibilities. Volume flexibility, a measure of a system's capability to be operated profitably at different volumes of the existing part types. Expansion flexibility, the ability to build a system and expand it incrementally. Routing flexibility, a measure of the alternative paths that a part can effectively follow through a system for a given process plan. Process flexibility, a measure of the volume of the set of part types that a system can produce without incurring any setup. Product flexibility, the volume of the set of part types that can be manufactured in a system with minor setup. Aggregate flexibilities, program flexibility, the ability of a system to run for reasonably long periods without external intervention. Market flexibility, the ability of a system to efficiently adapt to changing market conditions. Benefits on flexibility. Today's manufacturing strategy is to seek benefits from flexibility. This is only feasible when a production system is under complete control of FMS technology. Having in mind the process product matrix, we may realize that for an industry it is possible to reach for high flexibility by making innovative technical and organizational efforts. See the Volvo's process structure that makes cars on movable pallets rather than an assembly line. The process gains in flexibility. The Volvo system has more flexibility because it uses multi-skill operators who are not paced by a mechanical line. Advantages and disadvantages of FMS implementation. Advantages: faster, lower cost changes from one part to another, which will improve capital utilization. Lower direct labor cost due to the reduction in number of workers. Reduced inventory due to the planning and programming precision. Consistent and better quality due to the automated control. Lower cost unit of output due to the greater productivity using the same number of workers. Disadvantages: limited ability to adapt to changes in product or product mix. Example, machines are of limited capacity and the tooling necessary for products, even of the same family, is not always feasible in a given FMS. Substantial pre-planning activity. Expensive, costing millions of dollars. Technological problems of exact component positioning and precise timing necessary to process a component. Cellular layout is based on the group technology GT principle. Therefore, it is called as group layout. This layout is suitable for a manufacturing environment in which large variety of products are needed in small volumes or batches. The group technology principle suggests that parts which are similar in design or manufacturing operations are grouped into one family called part family. For each part family, a dedicated cluster of machines called machine cell are identified. Generally, all the processing requirements of a particular part family are completed in its corresponding machine cell. In other words, the inter-cell transfer UT part should ideally be zero. Group technology is a manufacturing technique and philosophy to increase production efficiency by exploiting the underlying sameness of components, shape, dimensions, process route, etc. Group technology is the realization that many problems are similar and that by grouping similar problems, a single solution can be found to a set of problems, thus saving time and effort. GT and design engineering. Mechanical designer produces about 2 discrete new parts per week. Thus, even a small department designs hundreds of parts each year. Without formal methods, Designers cannot track the drawings. They duplicate or near duplicate many existing parts. Like the Hydra of Greek mythology, the problem feeds on itself. As more new designs enter the system, they become harder to track and encourage even more duplication. GT and manufacturing. Group technology benefits manufacturing in many ways. It reduces the number and variety of parts. Process planning for the remaining parts is easier and more consistent. Computer-aided process planning, CAPP, is an important tool for this. It uses the coded similarities to plan consistently, standardize, and accurately estimate costs. It then assigns the part to a GT manufacturing cell. GT work cells are different. The popularity of cellular manufacturing and work cells has grown, fueled by the adoption of the Toyota Production System, TPS, and its namesake, lean manufacturing. But there are problems. The developers of TPS, Taichi Ono and Shigeo Shingo, were pragmatists. The evolution of TPS was largely trial and error, long on practice, short on theory. From their writing, it is evident that Ono and Shingo had a wonderful intuitive grasp of the system, but their explanations of the why behind it are a bit muddled and somewhat rare. Process technology. GT work cells usually favor smaller scale, less automated process technologies that change over easily and fit the lower volumes. Machine shops are an exception. CNC machining fits very well with GT cells. CNC technology does not really cut metal faster. It reduces setup and combines operations. Benefits of group technology: throughput time, setup time, overdue orders, production floor space. Other benefits of group technology: easier to justify automation, standardization in design, data retrieval, easier, more standardized process plans. Cellular manufacturing, CM, refers to a manufacturing system wherein the equipment and workstations are arranged in an efficient sequence that allows a continuous and smooth movement of inventories and materials to produce products from start to finish in a single process flow while incurring minimal transport or waiting time or any delay for that matter. CM is an important ingredient of lean manufacturing. In order to set up a single process flow or single product flow line, it is necessary to locate all the different equipment needed to manufacture the product together in the same production area. This is in contrast with the traditional batch and queue setup, wherein only similar equipment is put in the same area. Under a batch and queue setup, products that need to undergo processing under certain equipment need to be transported to the area where the equipment is located. There they are queued for processing in batches. Such a system sometimes results in transport and batching delays. In a single process flow setup, the products simply transfers from one equipment to the next along the same production line in a free-flowing manner, avoiding transport and batching delays. The single process flow setup described above is an example of a work cell. A work cell is defined as a collection of equipment and workstations arranged in a single area that allows a product or group of similar products to be processed completely from start to finish. It is, in a sense, a self-contained mini production line that caters to a group of products that undergo the same production process. Cellular manufacturing involves the use of work cells, which is how it got its name. Since differently processed products need different work cells, a large company with diversified products needs to build several different work cells if single process flows are desired. Given enough volume of products to work with, work cells have been proven by experience to be faster and more efficient in manufacturing than batch and queue systems. Because of the free flow of materials in cellular manufacturing, it has the ability to produce products just in time. As such, no inventories that have already undergone processing at one station will be left unprocessed in another station. This prevents the build-up of non-moving inventories, which are products that have already incurred some production costs but cannot generate revenues because they are stuck somewhere along the process. Aside from preventing non-moving inventories, process issues are immediately detected by just-in-time production, since defective products are seen earlier than if products are manufactured in large batches and queued. One technique that cellular manufacturing can use to achieve just-in-time production is the pull system, wherein required inventories and materials are requested or pulled in by each station from the station preceding it. This pull can originate from the end customer itself, thereby ensuring that the products manufactured are only those needed to satisfy a customer order. This prevents wastes from products not being sold. It is not enough to simply arrange different equipment in sequence to make cellular manufacturing really work. Bottlenecks along the single process flow must be eliminated, usually by balancing the equipment capacities with each other. If bottlenecks exist, then the higher capacity equipment within the line will be underutilized. Balancing equipment capacities may mean choosing right-sized equipment that match each other and or combining two or small capacity equipment to match one large capacity equipment. In cellular manufacturing, production workstations and equipments are arranged in a sequence that supports a smooth flow of materials and components through the production process with minimal transport or delay. Implementation of this lean method often represents the first major shift in production activity, and it is the key enabler of increased production velocity and flexibility, as well as the reduction of capital requirements. Rather than processing multiple parts before sending them on to the next machine or process step, as in the case in batch and queue or large lot production, cellular manufacturing aims to move products through the manufacturing process one piece at a time at a rate determined by customers' needs. Cellular manufacturing can provide companies with the flexibility to vary product type or features on the production line in response to specific customer demands. The approach seeks to minimize the time it takes for a single product to flow through the entire production process. This one-piece flow method includes specific analytical techniques for assessing current operations and designing a new cell-based manufacturing layout that will shorten cycle times and changeover times. To make the cellular design work, an organization must often replace large, high-volume production machines with small, flexible, right-sized machines to fit well in the cell. Equipment often must be modified to stop and signal when a cycle is complete or when problems occur using a technique called auto-rotation. This transformation often shifts worker responsibilities from watching a single machine to managing multiple machines in a production cell. While plant floor workers may need to feed or unload pieces at the beginning or end of the process sequence, they are generally freed to focus on implementing TPM and process improvements. Using this technique, production capacity can be incrementally increased or decreased by adding or removing production cells. Cellular manufacturing requires a fundamental paradigm shift from batch and queue mass production to production systems based on a product-aligned one-piece flow pull production system. Batch and queue systems involve mass production of large inventories in advance, where each functional department is designed to minimize marginal unit cost through large production runs of similar product with minimal tooling changes. Batch and queue entails the use of large machines, large production volumes, and large production runs. The system requires companies to produce products based on potential or predicted customer demands rather than actual demand due to the lag time associated with producing goods by batch and queue functional department. In many instances, this system can be highly inefficient and wasteful. Primarily, this is due to substantial work in process or WIP being placed on hold while other functional departments complete their units, as well as the carrying costs and building space associated with built up WIP on the factory floor. Now in the end, let us summarize what we have learnt in this lecture. Manufacturing system consists of human workers, automation, and various material handling technologies configured in ways that create specific manufacturing system typologies. Information technology includes all the software, hardware, and resources that collect, process, observe and execute information required for different activities of the business. The greater use of IT has been made possible with the advent of latest technologies and tools which are developed to facilitate all business processes. A good IT information infrastructure in manufacturing has 5 levels. The lowest level is the control systems layer, which directly controls the equipment used for producing the product. Flexible manufacturing systems, FMSs, are the most automated and technologically sophisticated of the machine cell types used to implement cellular manufacturing. Cellular layout is based on the group technology GT principle. Therefore, it is called as group layout. This layout is suitable for a manufacturing environment in which large variety of products are needed in small volumes.